We're down here at Onboard Engineering at Tarrant Point. This is our maintenance workshop basically, where we do smaller sort of jobs, saltwater services, rebuild pumps, coolers, steering systems, that sort of stuff. We've got Danny here with us who looks after our Burraneer Bay workshop down there on the hard stand, and this is a pair of D9 Volvos out of a V48 Princess, and we're just going to show you the importance of getting the saltwater system serviced and what it means to actually pull these things apart and why we do it. So your salt water is pumped from the ocean through this heat exchanger core through the center here. The coolant flows around the outside, makes it a closed cooling system, so seawater doesn't actually go around your engine block. It makes it very efficient cooling, also protects it from rust, corrosion damage from the seawater entering your engine. This boat wasn't overheating as such, however it was due in time. As you can see here, this is a calcium buildup and it's blocking 10–15% of the cooling system cores. These are the aluminium housings that the copper nickel or bronze cores go in the center of. The next component we have in the saltwater system is the aftercooler. The aftercooler is very similar. It has a copper nickel core with fins on the outside. The difference with the aftercooler or intercooler, depending on how people like the terminology, is you have air that runs through here and salt water that runs through the actual core itself. So the boost air that comes out of the turbocharger is pushed in through the aftercooler at high temperature, often over 200 degrees. And the job of this intercooler is to drop that intake air temperature right down as much as it possibly can, mostly at high speeds, around that 40 degrees or even closer to seawater temperature on some coolers. That means the air's more dense, more air, more fuel, more horsepower. These aftercoolers are a really great example of why you have to do a saltwater service. A lot of people will tell you that you can put a flush through the system while it's in place, and it is true, you can put a flush through the system, and that flush will eat all of this calcium and open up your cooling system and stop the overheating. What it won't do for you, and what we do and why we won't do a flush in the boat, is it won't give you access to check all these sealing surfaces. You wouldn't see the turbo gas that's pushing through here that's discoloring the air side of the cooler. You'd only see, and you'd only be targeting this saltwater jackets. You wouldn't notice the corrosion starting to form around the ends if the O-rings were leaking. And worse still, with this side of the engine being that it is salt water cooling the charge air, if salt water was to push past one of these O-rings due to corrosion or a failure of something like that, you would end up with saltwater ingress into your engine, saltwater into your pistons, into your combustion chamber, causing a lot of damage, a lot of money, and a lot of heartache. The transmission oil goes around the outside here of the core. The salt water goes through the center of the core. Again, this is a vital part of the system, and if you did have any failures with the O-rings, with the housings, you're going to end up with saltwater contamination in your transmission, or the other way around, where your transmission oil is pushing out through your saltwater system. This ends up in the river, in the ocean, in the environment. This also means that you lose hydraulic pressure and drive to your transmission, which often ends in severe damage to your transmission. We don't just remove the major components, we remove all the piping that relates to this system. As you can see, over time and over the age of these engines, these pipes get rusty just from the environment they live in. We bring them back here, we'll clean all that up. We'll clean up the sealing surfaces. That goes next door into our spray booth. That gets re-undercoated and coated in 2-pack white paint, the same as the rest of the components, mostly for protection, but it also makes your engine room look like it's your pride and joy like the rest of your boat. So the boys are going to put these through the cleaning solution, and you'll be able to see the before and after of how good these products work. The CFS to clean the salt water side and the calcium and the descale out of the cooler cores, and we use another Cleaner Works product that we use on the aftercooler cores, which gets rid of the turbo soot and the black stains basically, and the carbon buildup that comes from having a closed crankcase breather system on a diesel engine. This is our hot pressure washer. This is used once we've soaked the components in the CFS and give them the chance all the calcium come off. We bring them here and we hit them with the hot wash and take the last of the cleaning solutions off them. As you can see, that's the finished product of the heat exchanger core. Huge difference from where we started. This is our gear cooler. will get degreased again and cleaned up. There's a bit of where the oil sits on the degreaser. And this is the intercooler core. As you can see, there's no contamination from the carbon or the turbo boost air going through there. That's all cleaned up with the CFS, and the drift off, which is the other product we use by Cleaner Works, nice and clean on the salt water of the cores, completely clear of any calcium. Those gasket surfaces or eye-ring surface will get cleaned up, ready for reassembly and pressure testing. Well, we've just cleaned one of each of the components, just so as you can see the absolute night and day difference from when we started. So before, after, the end caps, before and after, the transmission oil cooler. And this is the other big difference, as I spoke about, between doing a flush and doing the system properly. The air side, the air side. This is what you won't get from doing a flush. It's not just the salt water that gets blockages and gets contamination, or it gets a coating on it where you're not going to get the heat transfer. As you can see here, this is the unit that's just been cleaned, spotless on the coolant side as well as the salt water. This unit here that hasn't been cleaned, you can see the discoloration and the start of where it's going to build up and cause poor heat transfer through the heat exchanger.
We're just checking some titanium plates for the new MAN heat exchangers. So every so often they're due for a saltwater service, and that includes changing the seals but also checking the titanium plates. So to ensure they got the maximum efficiency, we got a chemical solution. They get soaked in, they get scrubbed by the boys and inspected. So any that don't pass will get put to the side and be replaced with a new genuine part. If all clean up okay, they're reassembled in the stack, new seals, and then put back together onto the main housing. As you see, each plate will have salt water running one way, and then when we flip over to the next plate, we'll have coolant running. So it goes coolant, salt, all the way towards the end where it switches to salt, fuel. It's important to do both sides because obviously the coolant will over time degenerate or degrade, and so that'll leave a film on the plate. So a lot of people will think just running a flush through the system will solve the problem. It cleans the salt side, but it won't take the film left on the coolant side. So that'll leave a layer which will insulate it, so you won't get the cooling efficiency. The other thing that's not taken into consideration is the seals themselves. It's a rubber seal. It's only got a shelf life of how many years, and it depends on the conditions that the vessel's been running in. So they can go hard and brittle over time, and what that can happen is cause other leaks. If one of these back plates leak, what can happen? It can leak on this aluminium housing. Salt and aluminium really don't like each other. The salt will attack it. The salt's like an acid, so if the salt gets back on this face, it'll start eating away at the aluminium. And by the time you actually know there's a problem, this could be all ruined beyond repair. Then you're up for a new housing as well. So we always recommend following the maintenance schedules recommended by the engine manufacturers. They know best, they built the product, they know what lasts, what doesn't. But we believe in doing things right the first time. By following the plan, doing everything properly, everything comes apart, gets serviced, and if the saltwater service is missed or delayed or not done properly, these other parts can fail. It incurs much larger costs and unexpected downtime for the customer. So instead of being down for, say, a period of 5 days, this engine could be off the road for 5 weeks. So that all could have been avoided if the saltwater service is done right the first time around.